Hey everyone, welcome back to week 6 of this quarantine lesson. So, for today's lesson, we are going to be looking at reaction rate, but more specifically at rate law. Okay, so what is the rate law? The rate law is the rate in respect to concentration of reactants. In other words, we're going to be looking at by changing the concentration of reactants, how does that affect the rate? In other words, if you were to uh, double the concentration or triple the concentration, how much would the rate increase by, or would it have any effect on the rate? Okay, so here's the equation for the rate law. Rate, which is the speed of the reaction, is equal to k. K is a constant, the rate constant. And with the thing with the rate constant, it shows the relationship between the concentration of the reactants and the rate, and it's dependent on the temperature, which is something that we're going to be looking at later on. Okay, times the concentration of the reactants. Notice it's in brackets to indicate the concentration. Typically, we use molarity for that. Okay, and lastly, to the power of n. So this n is your. It's called your. This is called your reaction order, or the order of the reaction. Okay, the order of the reaction you can typically get 0, 1, 2. So it's going to be a whole number. Right? And how do we determine the reaction order? Is based on experiments, which I'm going to show you in a bit. Okay. Um, why don't we take a look at this first example here? And we're going to try to calculate the reaction order, and I'm going to go over what it means, this order. Okay, let's take a look at the bottom. Scroll down. Here we go. Here's my reaction. You have A plus B yields C. Okay, so for this reaction, you have two reactants. You have A and B. Okay, right below you have a table, and this table shows you three different experiments, 1, 2, and 3. And you notice, based on the experiments, you have different concentration for A and B. And to the way right, you have the initial rate of the reaction itself. So, for example, your first experiment, concentration A is 1.00, concentration of B is going to be 1.00. That's your rate, 0.40 moles per second. Okay. Your second experiment, you're changing just B, that's your rate. And your third experiment, you're changing A, and of course, that is your rate. Okay. So, how do we determine the rate law based on these experiments, or how do we determine the order for each one? Okay. So, I'm just first, I'm going to set up the equation. Rate is equal to K. What's my two reactants? A. I'm going to put in brackets to indicate the concentration. To the power of n, which indicates the reaction order. Okay, times. Remember, there are two reactants. Concentration of B, and instead of n for the reaction order, I'm going to use another variable, so I'll use P this time. Okay. Here's my rate law equation, and what I need to do now is I have to figure out the reaction order for A and B based on the experiments. So let's start with A first. So based on A, what I need to do is I need to pick two experiments, and I'm going to set up the ratio to solve for the reaction order. Okay, so the two experiments that I want to pick for A, it has to change. You can't have two experiments where A stays the same, and you have to make sure B stays the same. So for example, I'm going to use a different color ink. I'm use green for A. Okay, I'm going to pick experiment 1 and 3. Okay, here it is. 1 and 3. Okay, notice for A, I'm going from 1.00 to 2.00. And for the B, notice the concentration stays the same, because you just want to see, by changing the concentration to A, how does that affect the rate. And it looks like it's going from 0.400 to 1.60 molar per second. Okay, so next, I'm going to show my work. You could probably do in your head to kind of figure out the reaction order. If not, again, I'm going to show you how I'm going to set this up, okay, using ratio. Okay, so again, I'm doing what 1 and 3. So on the left side of the equation, you have your rate. So I'm doing rate 3 over rate for your first experiment. Okay, concentration to A, again 3, third experiment over the first experiment. Okay, so just when you set up the ratio, it makes it easier. You put the bigger number on top. Okay, so for the one, it's gonna be 1.60. Okay, over 0.40. Okay, set it equal to concentration. You have 2.00 over 1.00. Okay, so make sure again, because of the rate law, it's to the power of n. And that's gonna be, and that's where you're going to solve for the reaction order. Okay, we don't need the constant when we're trying to figure out the reaction order, so I'm going to leave out k for the constant. Okay, so now I'm going to go back. I'm going to solve it. So 1.60 divided by 0.4, that would give you 4. Okay, again, you probably don't need a calculator. You can probably do this in your head. 2.00 divided by 1.00, that will give you 2. Okay, power of n. Okay, so it looks like the reaction order is going to be n is going to be equal to 2. Okay, so it looks like the reaction order for A is going to be 2. Okay, and again, I will come back to what this means if it's 0, 1, or 2. Okay, last thing is this. Let's try to figure out the reaction order for what was it for B next. Okay, so I'm using a different color pen. Let's use red this time. Okay, again, I'm doing B. So which 2 experiments do I want to pick? Pick something that's changing, but you want to leave A the same. Okay, so which means I'm going to pick probably 1 and 2. We're changing B, but notice for A, it stays the same, 1.00. Okay, so now I'm going to go ahead and see what's going to happen here. So again, I'm going to set it up, rate. Okay, I'm going to come back up, make sure. Okay, so the second one is bigger. All right, so rate over rate, I'm going to set this up. Concentration of B. Okay, 2 over. Okay, so the rate, notice as you change B, that stays the same, which is 0.40. So it looks like by changing the concentration of B, there is no effect on the rate. So it's still 0.40. This is 0.40. Okay. Then it looks like you're doubling the concentration. Let's see. Yeah, 1.00. So 2.00 over 1.00. Okay, power of P this time instead of N. Okay, so 0.40 divided by 0.40, that's going to give you 1. 2.0 divided by 1.0, that's going to give you 2 to the power of P. So P again is your reaction order. Okay, so based on this, if you solve for it, P has to be what? Has to be 0. Right? Because 2 to the power of 0 should give you 1. Okay, so there you go. Our reaction order for B, it's going to be 0. Okay, so I'm going to come back up here. Now we already know. I'm going to erase this. N is going to be based on this 2. Oops. Okay, last thing is this P. The reaction order for B, that's going to be 0. Okay, so what does this be, right? Since we solve for it, this can be 0. Okay, so let's figure this out. Okay, so if the reaction order is 0, that tells you by changing the concentration of the reactants has no effect on the rate. Okay, so if you notice, as we change, let me go back up again, based on your data, for B, as you change, for experiment 1 and 2, as you double the concentration, the rate stays the same. Okay, so whenever you have the reaction order 0, that means by changing that concentration, the rate doesn't change at all. Okay, now if N is 1, if the reaction order is 1, that means by doubling the concentration of the reactants, you double the rate. So if you triple the concentration of the reactants, that means you'll triple the rate, etc. Okay. Last thing is this: if the reaction order is 2, means by doubling the concentration of the reactants, you're going to increase the rate exponentially by 2. So if we look up here, just by looking at A, if you double the concentration of A for experiment 1 and 3, the rate's going to increase exponentially by 2. So in other words, you're going to go from 0.4 to 1.60. That's 2 to the power of 2, which means it's multiplying by 4. So the reaction order of 2 compared to 1, the reaction order of 2, it just shows you that it's much, much faster. That's it, okay? If you were to triple the concentration, that means the initial rate, it's going to be 3 to the power of 2, which means you're going to multiply that by 9, okay? And then, of course, if you quadruple it, that means 4 to the power of 2, okay? You can have a reaction order of 3, but that's super, super rare. So for this course, we'll just be looking at reaction order of 0, 1, and lastly 2.